One way to solve quadratics is by completing the square. This is based on your binomial square theorem in that we want our dimensions to be the exact same. So instead of having a rectangular form, we're going to have a square form. So what does it mean by solving the quadratic? So if I have the form ax squared plus bx plus c, I want to know what the x value is when this equals 0. This is also going to show me where the roots are. This is valuable information because with graphing, you find your vertex, but you might not necessarily find where your zeros are at. If you're truly graphing, you can find your vertex, as well as if you complete the square, then you can find your roots and get a more accurate hand-drawn picture of your parabola. So what exactly entails completing the square? With this process, you are going to have x squared plus some value here, we'll go with 14x plus c. So this is a value that we need to make it a perfect square. How do I find that value? What you do is you take your b value, divide it by 2, and square it. This will equal that c. So in our case, we have 14. So we're going to take 14 divided by 2, and we're going to square it. So that gives us 7. We're supposed to square it, and that's going to be 49. So this is going to complete my square. That's the 49. Now, it does get a little bit trickier when you are trying to complete the square for both sides. So for example, if I had x squared plus 6x plus our box equals 16 plus our box. Notice I put a box here. Actually, I should call it a square because we are going to complete the square. Right now it doesn't equal 0, and that's okay. We just need to complete the square, and that'll take care of everything else. So with that being said, I need to go ahead and complete the b over 2 squared. So in our case, we have 6 over 2. That's going to go down to 3 squared, which is 9. 9 now gets put in to both sets. Now, how does this help us? This helps us in the sense that this right here is based off of our binomial square theorem, in which I can factor. Going back a couple sections, we already talked about the binomial square theorem, in that this next part is going to just be x plus or minus, depending on what you have, b over 2. And then it's going to have a square on the outside. So in our case, we have a plus plus. So that means we are going to have x plus some value. It's the b over 2 value, which in our case was the 3. So we got x plus 3 squared equals, and on the right side we actually just add, that's going to be 25. So now we can solve this algebraically. I need to get rid of the square, so I take the square root. This now leaves me with x plus 3 equals plus or minus 5. Because when we take the square root of any number, it's going to give us the positive and negative values. I can now split this off in order to solve for x. So I have x plus 3 equals negative 5, x plus 3 equals a positive 5. Solve it algebraically, we get negative 8 and a positive 2. Now, for this case, we didn't have a number, a coefficient in front of our x. So this next example I'm going to go through is what happens when I do have a number out in front. Again, it's still going to go through the same process of completing our square, which is good anyway. So if I have, let's go with 2x squared minus 11x plus 12 equals 0. So the first thing you want to do you want to divide by the a value. So in our case, we're dividing everything by 2. So I now have x squared minus 11 over 2x plus 6 equals 0. Step 2, move c value over and add boxes. So I have x squared minus 11 over 2x plus our box. We have to move the c value over, which in our case is the 6. So now we have negative 6 plus our square. Step 3, complete the square. So that's the b over 2 squared. So for our case, we have 11 over 2 divided by 2 squared. So when I take that 11 over 2 and then I'm dividing it by 2, that really means I'm going to have 11 over 4, and then I have to square both sides. So I'm going to add in then 121 over 16. You can do that on your calculator and it'll give you those values. I'm not too worried about that. Step 4, factor. So we've got the x plus or minus b over 2 squared. So in our case, we have an x, it's a minus, so we go with the minus here. It's going to be 11 over 4 squared, and that's going to equal 25 over 16. Step 5 here, square root both sides. Step 6, we'll just write it down already, split to solve. Okay, so I'm going to square root both sides. With that being said, remember it's the plus minus. This leaves it as that x minus 11 over 4. That's going to equal plus or minus 5 over 4. You can do this when you're taking the square root of a fraction. You can square root the top and then square root the bottom. The nice thing when you're completing the square, you know it's going to come out to a number. It's not going to be some number that is not able to take a square root of. So that's the advantage of completing the square. So now I am splitting to solve. So I've got that negative 5 over 4 plus 11 over 4, which gives me x equals 3 over 2. And on the other side, I have a positive 5 over 4 plus that 11 over 4 gives me x equals 4. So this is how we complete our square. This is going to help us to find our roots, as well as being able to get a better idea of what our parabola looks like.